Hi there. Welcome to the Data Career Roles webinar. We are about to start in 5 minutes. So just, let's give another 5 minutes so that people can join. Apparently, there's a mistake on the Zoom link. We apologize for that. Some participants are following another link that was sent previously on the email. So as soon as that's fixed, we should have everyone here on board. So just some notes. For today, we have the lead data scientist at OLX, Alexey Grigorev, as our special guest. So thank you, Alexey, for being here today with us and sharing your experience with the community. The idea here of the webinar is to really make it interactive. So if you have any questions about any of the slides, don't wait until the end to ask us. Just feel free to write it in the chat during the presentations, and we stop when we have the chance to read them and answer to them.
Yes. Hi. Thank you for inviting me.
Welcome. Yes, and the other thing is that we are recording this Zoom session. So if you don't want to appear there, you can not say anything. So don't use your microphone. You won't be in the recording. I think for now, by default, you're all muted. So that's why also we want to use the Q&A, the chat for the interactions. So don't have to worry about being recorded. Okay, so I think we are ready to start. So I will share the slides here. So the first, again, welcome to you that joined us after. The first slide we have here is about data career itself, and it's a motivation on why we are doing this. So the quote says that AI and data science is still some field that is young, and that only with 4 or 5 years of experience, you can become a senior AI researcher, or you can become a lead for an institute. And the idea here is that we want to provide with as much information as possible for anyone that is thinking about pursuing a data career, or anyone that is has already started their data career can progress in those 4 to 5 years to become a lead. So a bit of introduction about me. I am Dania. I am a founding member of the AI Guild. I work as a data scientist with machine learning models for predictive analytics mainly. Before, I was a bootcamp teacher at a data science bootcamp, and I am in the data career since 2012. So I started as a marketing analyst and then moved to data scientist. Alexey, our special guest for today. So Alexey has a background in software engineering, so 10 years of experience there, and then in machine learning and data science for the last 6 years. Alexey also is the author of the book Machine Learning Bookcamp. I believe he will say some words about the book. And yeah, you can connect with him in LinkedIn or on Twitter. I will publish the slides for today, and then you can also click there on the links to connect with both me and him. So what we are going to do today is we have some concepts for you. So first, some words on the AI Guild career coaching and why we are doing this event. Then we move on to talk about the different roles or the specialized roles in data. We also talk about the skills that each of the roles demand. And then we have some orientation on the career itself, especially for people that are starting or they're thinking about pursuing a data career. So a few words about the AI Guild. The AI Guild is the go-to community for data and business professionals advancing AI adoption. We have 3 main pillars. So the first one is the community. Then we have Data Lift, which is a series of online events, again in Zoom, that we are showcasing use cases for AI, analytics, and machine learning. And the last one is Data Career. So the webinar of today, the one that we are having now, is about the third pillar, the Data Career pillar. Everyone that is working in data, be it on the technical side, on the business side, is welcome to join us at the AI Guild. And you can also follow us in different social media. So if you want to follow on Twitter, on LinkedIn, Medium, and on Eventbrite for the upcoming event. So on the data career side, our main efforts for now are about this predictable path to a senior level. So we are providing this as data career coaching program. You can apply, or you can check more information about the program itself at the aiguild.ai/career. And here we have some 5 things that we are doing. So this is what is there in blue. So first is the assessment of your competency profile. So this is mostly for people that are in the 2nd or 3rd year of their data careers already, to understand what is it that you already have as competence and what is it that you need to pursue next to achieve the senior level as soon as possible. And then clarity about the professional mission is the 2nd point. Those 2 together will give the 3rd point, which is guidance on priorities on what to do to develop professionally. We also make part of the program that we coach on team and stakeholders communication, so internal and external communications. And lastly, but not less important, is the alignment between your data skills and the business impact that you want to have. So from doing this career coaching, we started this in 2019, and before it was mainly for AI Guild members, only for the community members. Now we are expanding this because of the pandemic situation and social distancing and all. We are doing this remotely, and that also opens up more possibilities. So for different people to join, people that are not physically at the same place that we are based in Berlin. But since we are doing this since 2019, we have some of the insights. So this is what we are sharing here in the slide. So the search for the first role or even a second role may take up to or more than 6 months. I think especially for this year and everything that has developed since the pandemic, it could even be more than 6 months. That means that also upgrading inside a company might be easier. That means someone that is already in a company, maybe working as data analyst and wants to move to data scientist, for example, might be easier to get that inside the same company. The other thing that you might already have realized if you're looking for a position is that job advertisements are confusing, misleading, because a lot of the times different companies, they understand differently what is it that is the main competence or even the main responsibilities of the different data professionals. So between data analysts, data scientists, data engineers. And the other thing is that once you land a job and you get to start working for a company, what you have, your tasks, what you have to do every day might be different than what was described in the job ad. So that's why we are here today. We want to address a bit of that and also understand that from what we observe in the market is that a lot of roles, they are coming up because the field is trying, or the market is starting to understand that they have different responsibilities and that they demand very different skills. There's also the rising value of domain expertise. That means, for example, knowing about the company business, or maybe understanding more about where the project is running. For example, if it's in logistics, supply chain, or if it's in marketing, that kind of knowledge is adding more value. And yeah, there is an increasing focus on deployment, which is connected to the experimental phase or the proof of concept cycle starting to move forward. Can you hear me well?
Yes, I can.
Yeah. So the audio should be fine. I don't know how to pronounce it, but Cookie is asking if we cut the audio. should not be cut. Okay, so that was the brief introduction about the AI Guild and what we are doing in regards to career. Now we can talk about the role specialization. So this is the part where I have a bit more to say, and then we move forward to Alexey. So here I brought up this image that was originally published in black and white in a paper by the Google researchers. And I added some colors here so to define what would be the main responsibility for each of the different data roles. So we have here 5 different roles. The first one in blue is data engineer, and then in yellow, data analyst, in red, data scientist, in gray, machine learning engineer, and in green, the AI researcher. So the idea is that data collection, data quality, and data pre-processing, for example, those would be the main tasks for a data engineer. And all of the pieces that are there in this diagram, this is every piece that is part of the end-to-end machine learning. So all the pieces that one would need to look at when productionizing machine learning. For example, here the data analyst is in yellow with analysis, business logic, and A/B testing. And the data scientist with feature extraction, parameter configuration, and offline validation. So I think that parameter configuration here is about the machine learning model. So the machine learning engineer here has the configuration, machine resource management, the overall infrastructure for the entire end-to-end project, any kind of management tools, and also monitoring. And finally, the AI researcher is the main box is the machine learning model. So here the idea is that the researcher is the person that is developing a new model, and then the data scientist is basically using that model, configuring it to work with the data of the company. That's why data scientist here doesn't have the machine learning models box. So if we look a bit deeper into each of the tasks and skills, here, for example, the data engineer, the task is to build and maintain infrastructure and pipeline to collect, clean, and pre-process the data. So the skills around that have to do with distributed systems, databases, software engineering. It is similar to the machine learning engineer, or the one in gray on the other side of the slide. There, the task is to optimize, deploy, and maintain machine learning models in production. So the task is different, but the skills are similar, again, software engineering, DevOps, and systems architecture. For the data analyst in yellow, the main tasks are around business and data understanding to report on what happens or what happened already. The main skills are descriptive analytics, SQL, statistics, dashboarding, and visualization tools. For the AI researcher in green, as I previously mentioned, it's about building new machine learning algorithms or find custom scientific solutions. And then the tasks are really research, presenting at conferences, and writing publications. The last one, the data scientist, the main task is about understanding the business case, building features to train predictive models to address such use cases. And then skills are statistics, SQL, programming, for example, in Python or R, machine learning, and deep learning techniques. So also a disclaimer that this would be the main or the core description of the core tasks or core skills. What we find nowadays is a combination of those. So there is no 100% data engineer role or 100% data scientist role. It's more of a mix of those. But here in the description, I try to keep it simple and just put the core tasks and core skills for each of those roles. Doesn't mean that you won't do or you won't find in the market, or even if you are working already as a data scientist or any of the other roles here, that you don't do any of the other tasks or you don't have any of the other skills. Yeah, so to try to make it easier for anyone to understand, even someone that has not worked in a model, putting a model to production. So I have this metaphor here about cooking with data. So if we think about this concept for productionizing machine learning as cooking in a professional manner, so that is not cooking at home for yourself or your family, but really cooking as a chef in a restaurant to serve a lot of customers, this is how we would probably look like. So all the blue boxes, that is the data engineering boxes, they're about the ingredients. So we can think about data as the main ingredient for your dishes. And there you have to sow, you have to harvest, and then you have to collect and prepare your ingredients. Next, you have to choose which recipe you're going to cook. So that would be an analysis. When you're exploring your data, you're understanding what you can do with the data you have. And then the feature extraction, for example, would be to use kitchen utensils to prepare the ingredients. For example, using a knife to cut or using a peeler to peel some vegetables. The infrastructure, so the box that comprises from beginning to end, this would be as your kitchen space and all the available appliances you have. So you can only work with what you have available, and that's your infrastructure that tells you. The parameter configuration of the modules could be thought like trying different combinations of appliances and recipes. So for example, you try to use your oven to cook, or you use the microwave. And once you are done, so you prepared your dish and it's done, you can do some offline validation. That would be when you're splitting, for example, your training set and your test set. So you're testing your solution that you trained on the training set. That is like the kitchen tasting. So something that the chef or the people working there in the background, they taste before sending the final dish to the customers. And the A/B testing is something that is after you already push this to deployment. So your users are interacting with your solution. And that is like the customer's tasting after you have people eating your food, what they think about it. So in this metaphor, what we see is that the data engineer is someone that is processing the ingredients at scale. The data analyst is checking for the quality of ingredients and recipes and how they match each other. The data scientist is creating and using the recipes to cook. The machine learning engineer is turning one recipe into many dishes that can be served efficiently. And the researcher is building the kitchen appliances. So before we move forward, I would like to ask if you have any questions you can write on the chat, but I would like to hear from Alexey. What do you think about this? Like, how do you see this? Maybe if I go back here. Yeah. How do you see the different roles and how they match with tasks and skills?
Yeah, I think it really depends on the organization. So what you're saying is it makes sense, and um, some companies do follow that. But like, let's say if you take a startup, and then a data scientist would do pretty much everything. If you take a large company, then maybe there is separation. But again, like in some cases, data engineer is involved into machine learning. In some cases, is not. In some cases, machine learning engineer is involved in creating machine learning models. In some cases, it's not. So the lines are quite blurry, to be honest. So right now, there is no uh, there is no single industry standard when it comes to these roles. And even if we take data scientist, which is like probably the most ambiguous because it includes pretty much everything, like and if we take American tech companies like these giants like Facebook and Google, data scientist there means a completely opposite thing to what it means here in a Berlin startup, because there, let's say in Facebook, at Facebook, a data scientist is somebody um, who is mostly doing SQL stuff, for example, and doing experiments, A/B tests. And here, many companies in Berlin call this position a data analyst. So it's it's still somehow like people are trying to make sense of these roles. And even though like data science is now how old, like 8 years, still there is no clear definition what it actually is.
Yeah, it's still very young.
Yes, at the end, like it's up to the company. So like probably the best way to understand what is required from a position is to read the description and then ask, because like even if you read the description and it says one thing, then at the end, I think you mentioned that at one of the slides that it doesn't necessarily mean that you will be doing this job. This is just a wish from the hiring manager, but at the end, the actual job might be different. So it's not as clear as like a software engineer.
Yeah, it's tricky because you need to understand what the company wants, but sometimes even the company doesn't know exactly what they want. And so I think also one of the goals that we have with this kind of webinar is to bring more clarity into the situation. So it is still very fuzzy or blurry. And the more we also understand this, at least in our heads, easier it is also to have a conversation with the other side. But it's a very good point that it changes from company to company, or maybe locally it means something like in Berlin, but then in the US, it's very different. Okay, cool. So now if we can talk a bit more specific on the skills for each of the roles. Before we dive deep into that, I would like to hand over to Alexey. So you can have a presentation, maybe introduce yourself, what you are doing. Here I have just a screenshot about your CV and what you did before to give people some overview. But yeah, feel free to start.
Yeah, may I share my screen? I think I cannot share my screen. Is it intended?
Sorry, can you try again now?
Okay, yes. Thanks. So I think it will be easier if I do it from my computer rather than. Okay, this is my CV. Indeed, I'll just try to make it a bit more visual. And if you really want to read my CV, you can go to my website and have it. It's my first name, my last name.com. But like if I have a timeline of my career, is I started working like my career started in 2010 when I graduated from university. But even before that, while studying at university, I really liked some data-heavy subjects like classes, like statistics, time series analysis, digital signal processing, and I did a bit of research there. But when I graduated, such skills weren't really required back then. So in 2010, I started to work as a Java developer. And it was fun. I really liked doing this. I spent a couple of years doing that. But then in 2012, Coursera appeared. And I watched this Coursera course by Andrew Ng about machine learning. And that was the moment when I understood that while doing Java is fun, I really liked being a software engineer. I thought, okay, this is the thing I really want to do. And that year I tried to understand what I need to do to actually switch to data science. And it was especially difficult back then because this is the time when the field only appeared. So it was quite a while ago, and companies back then didn't really know what is data science and what is data science. And when I tried to like at that time, positions like that started to appear. Yeah, but in Europe, maybe in the States, it started to appear a few years before that. But in Europe, around that time, 2013, I started seeing positions. But when I tried interviewing there, they would ask if I have a PhD and if I had like a lot of years with Hadoop experience and things like that. none of them, like I didn't have any of these things. So I thought, okay, if they require a PhD, and it seemed like I really I really like this thing. So I thought, okay, I want to do that. So I decided to do a master's. So I enrolled into a master's in business intelligence. This is how I ended up in Berlin. So I studied in Berlin Technical University. It was a lot of fun. So I met a lot of nice people. And also at the same time, I was freelancing. So I tried to already, before graduating, get some skills needed to work as a data scientist. Uh, Interestingly, for freelance positions, it was a lot easier to get a project compared to a full-time position. But when I graduated in 2015 from TU Berlin, the industry changed. So over these 2 years, it seemed like at least in Berlin, companies knew better what they wanted. So they realized that PhD is not really needed anymore. It's a good advantage, but it's not a must. So it's not a strict requirement for a data scientist to have that. So I started working in Berlin. I changed a few companies, and now I work at OLX Group. I first joined OLX Group as a senior data scientist, and now I work as a lead data scientist. For those who don't know OLX is a online classifieds website. So it's like eBay Kleinanzeigen or Craigslist in the States. So basically, it's a place where you, if you want to sell something, you go there and sell it, and if you want to buy something secondhand, uh, this is uh, uh, this is where you go to buy it. And as a lead at OLX Group, I am involved in many things, but I was thinking how I can group all these things. So in addition to doing a bit of hands-on stuff, I do that a lot less than previously when working as a senior data scientist. I'm involved in many other things. So there are sort of three pillars. One is education and mentorship. So it's about guiding people, helping them to be more independent and train models and deploy these models and help with advice and do things like this. So basically, it's like weekly by weekly one-on-one meetings where mentees tell me about their problems and we think how we can solve these problems. Now, I also do a lot of trainings like for engineers or for even non-technical people like finance and HR to tell them to tell them about the value of machine learning, what it can do for the company. Um, and often, like if there is a new piece of technology we want to evaluate it, I can do a quick proof of concept and see if it's something we want to use or not. And then teach others, like if I think this is useful, I can show that to others and see, okay, this is how we use it. Then another part is more product and business oriented. So it's like just understanding what is going on around and if there are any areas where machine learning can improve, can help. So I want to know everything that's happening where machine learning is involved, and have meetings with people, understand the requirements, document everything, get the business context, and also then share this business context with other team members. And then the final part is architecture and infrastructure. And usually this is the most difficult part for data scientists. So let's say we have a model, right? So usually it's not the most difficult part. So there are a lot of tools to do this. We get the data, but then, okay, once we have a model, sometimes it's difficult to make sure that we can serve this model on scale because um, we have a lot of data, a lot of traffic, and it's not always easy just to get a Flask API, put a model there, and hope it will work. Usually, it's not enough, and then we have to think about the way we design our infrastructure so it can cope with this load and also doesn't cost a lot of money. So this is what I'm doing as a lead data scientist, and I think the most important distinction between a senior data scientist and a lead here is that a senior data scientist is more hands-on, uh, it also spends less time with educational activities and maybe this broader business scope, business understanding. So I think if a senior data scientist wants to get to elite data science position, so these are the key areas that where they should focus, like teach others and have this business context in mind when thinking about solving problems with machine learning. And now I'm looking back at my career, at my journey, and I am thinking if I'm not sure if the way I ended up in the position where I am now is the most optimal, because I think some things maybe I could have, let's say, accelerated more and start making more impact sooner. So, for example, while I really enjoyed doing my master's, I'm not sure it was really the best investment in terms of return on investment. While I met a lot of people, I learned many new things. But at the end, it was actually 2 years that I spent uh, studying things that at the end, most of them I didn't need. So uh, I had a class about machine learning, but then to understand what's going on in this class, I actually had to take online courses. And for taking online courses, you don't need to have masters, right? You can just go to Coursera, you can just go to EDX, you can just go to any other platform, or just read a book and get these skills, right? Then the most useful thing from the university was my thesis. That was indeed super helpful because I think it was like a real life project, a real life application of machine learning on real data that is solving a real problem. And I think this is what was really helpful, like as a result of my master's. And this is what, for example, when I get into search metrics, my first full-time job as a data scientist, we talked about that. We talked a lot about my master thesis and all the things I did there. So it was like a good use case. And I think like if I wanted to do this again, I would probably skip this part and from online courses jump directly into building uh, like a project, like a side project. Like in this case, in my case, it was a thesis, but I didn't have to study 1.5 years to actually do this. I could jump straight on that and solve that problem and then showcase it during the interviews. And then that would have given me, let's say, 1.5 extra years that I could have used to do something like have a business impact. So I don't know. I really liked my master's, but when people ask me today, uh, like, do you like ask for advice, asking like, do you think I should get a master's or not? I usually say I'm not sure. Like maybe you don't need to spend 2 years. Like if everything you need is to learn some things from online courses and then do a project and then find a job. Another alternative could be a boot camp. I know we have many in Berlin. We have many in other cities. I think it's a good option as well. It's 3 months, so it's not 2 years. Um, so perhaps like if you're thinking of going that way, yeah, so it could be a good alternative to a master's. But of course, like if you want to do research, then master's is the right thing to do. And actually, I was thinking of doing research. So one of the reasons I did a master was that I thought I would do a PhD, but I didn't. And I think that a software engineer is a really good background for a data scientist because um, like this is a picture of one of the systems we have at OLX from a different presentation that I had. Like it's a moderation system. Like the details here are not important. What important is that we have like a big complex system with many, many things, right? And machine learning is just a tiny part of that. But to make it work, to integrate it, we need to do a lot of work around this um, to, to somehow place it into an existing system, which is where like this is the most difficult work. Like training a model maybe is difficult, but at the end, compared to other things you need to do to actually make business impact with this model, these things are more complex. And this is what Dania already presented previously. I took the original, and these are all the things that we need to do to be able to serve a machine learning model. And if you see, if you look at this, so we have a tiny little square here that says ML code, and the rest is like other things that we need to do. And these things are mostly engineering work, like all these tools, all this configuration, all this infrastructure. This is what software engineers need to do. Like you can call them data engineers, you can call them machine learning engineers, but at the end, they're engineers, right? So it's mostly engineering work. And I think for getting into this field of data science, machine learning, software engineer is the best background. Not the best, maybe not the best, but it's a very suitable background to get there. Because, for example, uh, academics with PhD, they also have a very good background for getting into data science, but they have a different background. So maybe for them it will be more difficult to do these engineering tasks. But for software engineers, this is easier because they already have to deal with 90% of these things. So I think like what you need to do is focus on this thing, and uh, uh, this is what my book is about. Like it's for software engineers who want to really understand the core concepts of machine learning that they need to be able to do the job. And I'm still writing it, so it's like 80% finished. But I base this on my own experience of transitioning from software engineer to data scientist, and things that really work well for me are project-based things. Like when you actually need to do something, like you have a clear goal, like a clear problem you want to solve, and you focus on solving this problem. And this is what I use in the book, like for project-based learning. And I think this is the most effective way for software engineers, in my opinion. Of course, people are different, but in my opinion, um, this project-based learning is one of the most effective ways to actually get the skills that you really need to do the job. And for me, when I was studying, it was my thesis project, my freelance projects, and when I took part in Kaggle competitions. So I think this was really great, great project-based learning, because in all these cases I needed to solve a specific problem using a tool, some tool. And when I didn't know about something, I would Google, I would find how to solve this problem and solve it. So instead of going deep in theory, not knowing when to stop, I really had to focus on solving a specific thing. And for engineers, I think like they already know most of the things they need to know to be successful. They just need um, to get familiar with the core concepts of machine learning, like how to set up data validation, how to train a model, how to make sure you don't overfit, and things like this. And in my personal opinion, that could be picked up relatively quickly, like compared to people who do not necessarily have this coding background. And like a bit of an advertisement. So like if you're a software engineer or a DevOps engineer, right now at OLX, we're hiring for a senior site reliability engineer. So this is basically like a DevOps engineer or a MLOps, if you wish. So here, like if you don't know machine learning, but you know DevOps stuff, and you want to get more into machine learning, so this could be a good position for you. So please check this position, and if you're interested, apply or reach out to me on social media. And similarly, I think doesn't have to be OLX. Let's say if you're a software engineer, try to find a role that emphasizes your experience and try to get there, and then use your experience to go like to, to to learn more about machine learning. Let's say it could be a machine learning engineer or data engineer, some sort of engineer. And I think my part. I think I should stop sharing now.
Okay, thank you.
Yes.
Maybe we can take the switch time to answer some of the questions that were posted on the Q&A. So the first one from Verena. I think we answered already, but she asked, are the roles in reality so clear cut? Or do the tasks blend between roles? If not, all roles are filled in every company. Yeah, so there is a mix, or there is a fuzziness in the definition of each of the roles, at least in the companies I have worked for so far. Especially as you said already, Alexey, if it's a startup, you're basically doing all of it. So you are wearing the hats of analyst, scientist, and engineer as required.
Yes, I
Okay.
agree.
Do you want to add something?
No, I think we covered that already.
Yeah. So there is another question from Anonymous. Any books you would recommend for getting proficient with machine learning? I think your book.
Yes, of course. Well, there are other books. I think what important here is like reading one book, reading two books is good, but do not try to, buy a lot of books, buy a lot of courses, and think that this is enough, because it's not. Like, you need to also learn by doing projects, or like somehow showcase your skills. And then for me personally, learning by doing makes these skills stick. And yeah, so do that. And for example, if you take my book, then at the end of each chapter, I put exercises, and I think these exercises are really important. So if you're serious about getting into machine learning, you really should find motivation to do these projects, or maybe not this project, but some other projects. And this will really help to for the concepts to stick.
Yes,
Yeah.
I agree. And also, when you have a project or you wrote some code, it's also something that you can use as a portfolio. So you can
Yes,
refer
definitely.
people to your GitHub, for example. The next question, also from Anonymous, what sort of math would you recommend to serve as base? So I actually have a background in mathematics, so I did applied math as a graduation course, and I think that the main thing that you have to learn is the concepts of linear algebra and statistics. I think those
And
are the basis, yeah.
and a bit of calculus. But if I really like, if I have to think about this, that this is nice to have, like if you want to understand the theory and do some derivations by hand. And this is what I learned at some point as well. And it was a lot of fun to me personally to to go from, okay, this is this is what I want to solve, and then arrive at the solution. And let's say for logistic regression, and seeing how elegant it was at the end, that was a lot of fun. But honestly, I think if you think like, if you want to start bringing value with machine learning right now as a software engineer, you don't really have to know all these maths. You need to know how to get your data from somewhere, from a database, prepare this data set, right? Set up a validation scheme to make sure you don't overfit, and then train a model using off-the-shelf solutions, right? And then be able to measure the effect of this model. And you often don't need math for that. So you can do just by using these tools. And so maybe just to understand what's going on inside, it's helpful to know a bit of math. But to get started, I don't think you really need to know a lot of mathematics. So
I
probably
agree.
enthusiasm is uh, like you should have enthusiasm to do this, not mathematics. And then if you have enthusiasm, if you really want to learn that, then the math part will come as well. But to solve business
Yeah.
problems, frameworks are enough.
Yeah, I think that nowadays we have enough tools already implemented so that it's not complicated to, as you were saying, if you have the data, to try out some models, because it's simple enough. What you really need to do, and you cannot skip this part, is learning some programming language so you're able to use the libraries that are available. What I can say from my background is that it's easier for you to learn a new or understand a new algorithm if you have the basics of, for example, linear algebra. Because then if you read the documentation, like you don't need to read all the papers, but you'll have an idea of what's happening. And that kind of abstraction helps you when you have to learn new things as you go, because there are always some new improvements or new algorithms, new implementations, and so on being released. and also gives you an idea how to, or gives you an understanding maybe faster or even before training the model if this model is a good idea or not for the kind of data or the kind of problem you're solving. So it gives you somehow a better understanding of what is behind the scenes, gives you a better hunch on what to pursue next or how to find a solution, or at least to understand why it's not working. A lot of the times it doesn't work, and then you are not understanding why it's not working. Maybe it's the data, maybe it's how you formatted the data, maybe it's just the wrong algorithm.
So I would add to that definitely it's helpful, but when people say, hey, you have to take, I don't know, 2 years of advanced calculus and then 1 year of linear algebra to do machine learning, and if you don't do this and you're not qualified, then don't listen to them. So definitely, like, if you...
Yeah, it's too much.
Yes. So some exposure, like probably the best thing, like, is just not being afraid of formulas, like, and have enough enthusiasm to, you know, not to get scared and really understand what's going on in these formulas. And then what I personally remember, like what helped me is being able to translate these formulas from like mathematical language to a programming language. And then it became clearer to me. So I think for other software engineers, it's also something that can help. Like, okay, you have this matrix calculation, but what, like matrix multiplication, but what is actually happening inside? And then once you try to translate this to like a programming language, then it becomes clearer.
Yeah, that's a good one. And I think while you do that, or the more and more you do that, like in your approach of doing projects and solving problems, for example, Kaggle has a lot of data sets, you can try it out. I think you end up creating some intuition on the things, why they are working, or you build up your knowledge when you understand some of the models, then this helps you understand the other models that are new to you. Okay, thank you. Let's see the next question from Ben, I don't know how to pronounce it. Hi, I would like to know if having a PhD, not in computer science, but astrophysics, and doing several postdocs make the chance of being hired less. Yeah. Do you want to take this one?
I can help with that if you like.
Hi and welcome, Chris.
Sorry, I got there was an issue with the Zoom live versus webinar link, so I was fixing that. So
yes,
hello from my side, and on this astrophysics thing, I would simply like to say that I had dinner on Saturday with an astrophysicist who had several postdocs positions and is now a chief data officer. So the answer from that example is it won't get in your way, principally speaking, because I'm guessing that your astrophysics is data heavy. So there are things that you do where you are already all the time data engineering, data analyzing, data. So this should work. Then, of course, the gentleman I had dinner with transitioned in 2015. Now it's 2020. So the field has moved on. It may take you a minute longer, but principally speaking, if you want to do this, go for it.
So I wouldn't say it's a disadvantage by no means. It's advantage, right? Because like as you said, it's data heavy, and to do many things, you need to use all these data tools, like be it MATLAB or Python or whatever. You still need to process the data. So I think that sometimes what I see for people coming from academia is it's more difficult for them to program, to code. And right now, often that coding is a requirement. Like if you want to get into data science, often you should be prepared to do a coding task during the interview, right? And my experience was that I saw people with great profiles, with great CVs, but they couldn't solve small tasks. Maybe because they were nervous, maybe because for some other reasons. But yeah, so my advice would be to try to, because you already have the background you need for for the data processing side, right? Like the right state of mind and you know, all that. But just work a bit on coding skills to show that you can solve these problems with Python, for example, because this is what mostly people require now, mostly companies require now. And yeah, so just try to work on that. Of course, if it's a problem, like, because for many people, I guess it's not. And then try to maybe add to this portfolio that you already have, these things that you did in your PhD, maybe add something more, let's say, down to earth, not from the stars, but something that companies can relate to, like a simpler project. And then also maybe it will help you in your discussions, in your interviews, to talk about. So I think because for many interviewers, maybe this domain is difficult to understand and they cannot ask questions to really assess your knowledge. But if you try to pick something else and then showcase that, you will have a lot of material to cover during the interviews.
Yeah, cool. Thank you. We have a related question. So from Han Yue, she wants to ask about moving from academia to industry. The background is mathematics and PhD in biostatistics. The main topic of the PhD is modeling the epidemic spread in Germany using R. Do you have some suggestions for changing to industry and less project experience in machine learning and Python coding?
I can perhaps also help with that by telling another story. AI Guild member now. So she's a biologist, or was a biologist by training, did a PhD, and I think was in a field of evolutionary biology and genetics. And a particular quip she had was, R is my native. So she was doing a lot of work, a lot of academic work in R. And then she decided during her postdoc to leave academia and find a data science job in Berlin, actually. And she understood that she didn't have any Python coding skills. So she looked at her holiday allowance and a few other things and got together 12 weeks to learn Python additionally to R. And in those 12 weeks, she basically did all the Python courses she could find on Coursera. So she kind of knocked them off one after the other as fast as she could, and after those 12 weeks, started applying for jobs in Berlin. And I can say that she very soon found a data science job with a reputable fintech in Berlin. And after about a year and a half, moved on to Europe's most valuable fintech company. So that worked.
Yes, that's a good story. Another good example to share. But I do think that, yeah, as Alexey also already mentioned, most of the companies are using Python. I think it also has to do with deployment, especially when you want to integrate your machine learning solution into an existing piece of software. But I also think that one should use the tool that best fits the problem. So sometimes, for example, I work with time series, and for that, there are a lot of R libraries available. So I don't think that only Python is important or only R is important, but if you can, for sure, add Python to your list of programming languages, I think that's an advantage. Alexey, maybe you want to add something to that?
No, I think I kind of answered that previously, but I think the question also was like which project to pick, right? If I remember correctly. And for that, I think like use your interests. Like if there is something that is interesting for you personally, like maybe you have some problem that you want to solve, then yeah, try to do that. And of course, I know it's not easy. It's not always easy to come up with an idea, but then try to look for inspiration somewhere, maybe like your favorite app or whatever. But then again, if you don't have any ideas, then there are companies like Data Science for Social Good, not companies, but like initiatives where you can pick up the skills by solving some meaningful problems, or yeah, do a Kaggle competition. That is
we
also.
have some. Oh, sorry.
Yes, please.
There's a related question to that actually. So Anonymous asked if there is a suggestion for selecting a master thesis in machine learning. is it more valuable to do with a company or with a research group at the university?
Depends on your goals, right? So whatever you like, if you want to stay in the academia, then I guess like it depends what you want to do in half a year, where you want to go to academia or industry.
Then yes, so indeed, if you want to go to academia, you would do it with the research group. If you want to move to industry, you would do it with a company. And then I have another quote or experience for you from a leading machine learning researcher in the Netherlands, who once reported about really working with a lot of startups. And then, he got pressured or pushed on why. And then it turned out that he thinks that companies often have the more interesting problems. So that was quite interesting, from an academic to hear that he thinks that companies have the more interesting problems. I mean, he's in the Netherlands, so this was a comment about Amsterdam, and OLX is in Amsterdam. But it probably applies in Berlin too.
Well, I guess like from what I remember from my personal experience studying at TU Berlin, to find problems that are like how to say theoretical on paper. Well, there are different kind of research groups, but some of them do want to focus more on applied side, but still they think long term. They often think, okay, we want to do the next big thing, right? We want to build something that everyone will use in 5 to 10 years from now, right? While in or like have some breakthrough, I don't know, like for example, the machine learning group at TU Berlin, they're working on brain-computer interfaces, right? So this is a very interesting problem. But in industry, the problems are very different. Like there are more simpler problems, a lot simpler problems. Like, okay, like how do we make our customers happy? Like maybe we just do a recommendation for them or like something like this. And they require less effort, like the feedback loop is faster. You can just quickly deploy something, learn from this feedback. While in academia, I think this feedback is takes more time, especially like even if you have a grant and work with some industry partner, then you share the results with them and then they get back to you like in half a year and then just make this a little bit more, like it takes a little bit longer. So while it's the case for me personally, I do also think that industry problems are more interesting. Like there are always like always different opinions, and for some people having more theoretical problems like they like it more. For some not. It's again like it really depends on the person.
Yes. Okay, thank you. I think that is very much the answer. There's no right or wrong. It depends really on what you want. They are different. There is one question again. Sorry, another question from Jen. What is the role of explainable AI in deep learning?
Well, okay, I'll try. Well, in general, like if we talk about machine learning, let's say if we take OLX example, we have a moderation system, and then when somebody creates a posting, we want to understand what is in this listing, right? What kind of images are there? What kind of title is there? Like, is it safe to publish or not? Like, is it fraudulent or not? Is there a not safe work content? And then show it to moderators. And when we do this, we need to tell the moderator why we think this is a suspicious ad. Let's say we think that because it's a fraudulent activity and this account was created like at the same time when a lot more other accounts were created, like yeah, just because it's suspicious, we want to show why it is suspicious, like to show the moderator where they should look, what they should look at. And by being able to explain that, like, okay, we think it's suspicious because of ABC reasons, right? So it makes it easier for them instead of, digging through a lot of things, they quickly know what to look for. That's one of the things. When it comes to deep learning, um, I don't have personally a lot of experience with explainable deep learning. Of course, again, if we talk about moderation case, sometimes, okay, the model thinks this image is not safe for work, but it's safe. Why? And trying to understand why, trying to debug why the model thinks this image is not safe for work, or the other way around, why this not safe for work image for the model is safe, and trying to understand what's going on there is really helpful, like this model debugging thing. And often we do this by trying to uh, understand. So we want the model to explain us uh, why certain predictions were made in a certain way. And there are many hacks for doing this. I'm not really an expert in this area, but there are different tricks that you can do to actually to figure out why a model made a decision in a certain way. So I think it's really helpful.
Yeah, and I think the main goal, if I understand right, also from your example, so thank you for the moderation example. I think it's about also getting people to trust the model, right? Like you understand better what the model is doing, then you can trust it more.
Definitely.
Okay, cool. The next question from Uziel is about a book to get proficient on data engineering. If you
Now,
know some.
yes, I know. It depends how proficient it is. I know a very good book about data engineering. It's more like about distributed systems in general. It's called Designing Data Intensive Applications. It's a book from O'Reilly with a peak on it. It's really good. Like it covers a lot of material, mostly theoretical material about
Okay.
how to build systems. So it's not just about data engineering, but a big chunk of it is about MapReduce and scalable data processing and whatnot, like things like Kafka, like queues topics, whatever. There is another big chunk of how to make systems scale. And I think this is quite
Okay.
important in a day-to-day job of machine learning engineers, data scientists, DevOps engineers, and also like
Okay.
basically everyone involved in building software applications, especially machine learning applications, because they are data intensive. So I think this is a really good book, but as I said, it's more theoretical, maybe aimed at more like intermediate level professionals. So if you really want to get into um, data engineering, then again, my advice about doing projects is probably best. Like I don't know a good book about that, but let's say you can just build a project, like it can be a machine learning project where you also take care of the data engineering part. Let's say you can build a model for predicting the price of a car, and for that you need to get data, right? And to get data, what you can do is you can go to eBay Kleinanzeigen or AutoScout or whatever website with cars and scrape it. But it's not enough just to scrape once, right? So you want to set up, let's say, a pipeline that does that every day or every hour. It goes to these websites, scrapes, saves the results. And then this is a good example of data engineering. Like you want to set up this data pipeline for scraping, right? And then at the end of like the output of this pipeline is a CSV file, or like not a CSV file, but maybe entries in your database. So this is what you will use for training a model. So if you do that chunk of data engineering, like actually getting the data and processing and putting it in the right form, I think this is probably one of the best ways, in my opinion, to learn about data engineering, especially if you're thinking more about data science and machine learning engineering rather than a career in data engineering. I think that should be enough to actually have the skills you need on a daily basis.
Yeah, thank you. So I think that is different than doing a Kaggle project, for example, joining one of the Kaggle challenges, right?
Yes, that's very different because in Kaggle you already have a CSV file, right?
Yeah, you really work on the modeling part.
Yes.
Yeah, cool. Thank you. And there's a question here from Norm. You mentioned working as a freelancer earlier. So do you recommend this to figure out if you like or enjoy the job before being committed with a company? If so, what freelancer platform do you recommend?
Okay, so maybe my experience of being a freelancer doesn't translate to general So what I want to say is like it was a freelance platform from Russia in Russian, so maybe it's not applicable for everyone on this call. It's called fl.ru, like it's well, basically it's a website in Russian. There are other website platforms like TopTal or how it's called. Like I think it's used to call. It was called Odesk. Now I think it's called somewhere else, but something else. But yes, if you just type freelancing platforms, you'll find many of them. I think it's like it's different from working full time. So when I was a freelancer, it was just sometimes okay, like this is the like first, like oftentimes the client already figures out what they want to do, and often it's difficult to convince them that they are not always right. And yeah, so like also you're not close to the business. Like if you compare it with working in a product company, then it's very different experience. So in freelance, I worked on a project for 1 month and then moved on. So I really was able to build a good portfolio, like of different projects. But that was similar to sort of doing Kaggle in a way, because there was a data, I just needed to train a model or build a pipeline there. But yeah, so just a small chunk of work and then move on. And I don't think that was useful to some extent, but yeah, I couldn't see the results of my work. I didn't know what happened with the things I built, or like sometimes, for example, the client wasn't satisfied with results and didn't tell why. Okay, I don't want to work with you anymore. Sorry. So it's yeah, and I think working in a product company full time, being closer to business, is a completely different thing. So, and what I'm trying to say is that experience working as a freelancer doesn't necessarily translate to experience working as a full-time data scientist. So there are some overlaps, but also many differences. So yeah, I think the best way to understand if you really like the job is to first try to build like a project maybe that you know, like this predicting the price of a car, and see if you like, in addition to training the model, if you like all the other parts, like preparing data and then serving the model, because this is what actually takes a lot of time. And other thing you can do is you can talk to people who are already working for a couple of years and ask them, what are the things you don't like about your work? And then yeah, so maybe oftentimes you'll be surprised what they tell you, and then you think, okay, in this situation, if I was in this situation, would I like this kind of work? Like, would I be able to force myself to do this or not? And, I think this would be more helpful to understand if you like this job or not.
Yeah, that makes a lot of sense. Yeah, really trying to connect with people working on some position or some company you are thinking about going. If you have the chance to talk to someone working there before, it's really good. Can give you some insights that are not in the job description, for example. Okay. We have one question here from Neil. How would you rate certificates from online courses? Are they even considered for a job application? I don't know, Alexey, if you are also doing interviews, like for hiring
I
people.
do interviews. Yeah, they don't have any like value to me, to be honest. I mean, it's cool that you do this. I'm really glad for you. I'm really happy for you. But yeah, apart from that, I have nothing to add. So this is not like, for me, what I value more is like when I go to LinkedIn, oh sorry, GitHub, and I see a project. Like this project could be coming from a course or your own project. I think this is a lot more interesting than just seeing a certificate. Yeah, but one thing that it can show, sorry,
Yeah.
one thing that it can show that you like learning. I think it's a good thing. So yeah, but other than that, let's say if I had two candidates completely identical, of course that doesn't happen, but let's imagine this scenario, and then one has certificates, another doesn't, and yeah, I don't think I would prefer that candidate with certificates.
Okay.
I have
And
I
there's
have
a
one
follow-up.
rejoinder. I have one rejoinder, if I may. I've noticed recently, I don't know how about the two of you, but I have noticed recently that practitioners that have been in the field for 1 year, 2 years, 3 years as data scientist, data engineer or so, on their LinkedIn now also have these competencies. And I've also noticed that some have used the training they did on Coursera, Udacity, FastAI, Deep Learning, whatever, various places, to then kind of give their career a little twist.
Mhm.
So I just somebody that I'm going to work with next week started out as a data scientist, but now got Google Cloud certification and did some engineering courses and is now actually also doing data engineering work. And it looks to me, I still need to verify, but it looks to me like he was using these courses to initiate the shift. Of course, then underpinned probably with work experience and projects, but I don't know. Have you seen this?
Yeah, I'm not against that, of course. I think so. These courses and certificates, they are valuable, but not the certificates themselves, but let's say the journey to get these
Okay,
certificates.
yeah.
Like, let's say if you're studying, if you're preparing for AWS certificate or Google Cloud certificate, and you did a course about that, then maybe you don't even have to take the actual certificate at the end, like, because you did the course, you already know the things you need. Then okay, having the certificate is nice, but you already have the knowledge because you prepared for this certificate.
That makes sense. Yeah.
Yes, but I think
It's
for
really about the learning, not about having some one
yes,
more line on your CV. Yeah.
I think for freelancers, it can be valuable, especially if we talk about certificates, because for clients who do not have internal capabilities to verify, like people who work already as data scientists, if they don't have these people, there is no one to verify if this person is like really knows data science or not. They can look at certificates, right? So it's like as a way to, okay, they have a certificate, so a certificate, they probably know something about this topic. But for a company, for a product company who already has data engineers, data scientists, I don't think it will give a lot of weight for the application.
Even if it's a certification on some specific cloud provider that the company is using. I mean, I had that thought, and also came the question if it's a cloud certification, I don't know, AWS, Azure, or Google Cloud Platform. You don't think, or you think it could make a difference?
Yeah, well, I think the important things more like how useful it is for a company. And usually, like let's say if we are talking about data scientists, there are other more useful things that we first want to check before AWS,
Okay.
right? And then it's not something that it's super difficult to pick up at work, right? Like if a candidate knows machine learning well, can program in Python, but doesn't know AWS, well, doesn't mean we will reject this candidate, right? We can hire this candidate and they will learn AWS at work.
Okay, cool. Thank you. It's really insightful also to hear from someone that is doing the interview, so from the other side. Thanks. There is a question here about deep learning framework. So which one would you recommend for the start learner, Keras or Fast AI? Well, from my perspective, I only learned Keras. I don't know much about Fast AI myself, but I don't know if that is easier or like to learn.
So
Do
from
you
what I
have some?
know, Fast AI is based on PyTorch and Keras is based on TensorFlow.
Yeah.
And probably Fast AI is simpler. I don't think like it really matters. Like as long as it helps you solve the problem, then both are fine. But when it comes to Keras, there is a significant advantage, in my personal opinion, is that Keras is baked by like it's based on TensorFlow, and TensorFlow has TensorFlow serving. So this is a special tool, special framework for serving TensorFlow models based on TensorFlow. And it makes it a lot easier to use models in production. So let's say if we have a model trained in Keras, it doesn't require a lot of effort to deploy this model because like there are these tools. with PyTorch, it's still more like it's more used in like more experimental setup in academia, like for learning maybe. It's more difficult to deploy PyTorch models than TensorFlow. So like I don't know. I don't think this is like there is right or wrong. Like you can go for whatever is easier for you. But for example, at OLX, we tend to prefer Keras and TensorFlow for this reason that it's simpler to deploy.
Okay, thank you. So we do have more questions, but I would like just to show the slides I have prepared. Maybe that will take another 5 minutes, and then we go back to the questions. That's fine for you?
That's fine, Dania. What I can say is that I've got on mute, as you have perhaps noticed. And while I've been doing that, I've been trying to answer as many questions as possible by typing in answers. And I'm assuming that people can also see them under answered. So in the Q&A, if you click to you should be able to see that I've been trying to help people as much as I can, and I will continue doing so.
Okay, thank you, Chris.
Yeah.
Okay, so I will share my screen again. No, it didn't work. Now it works. Okay, so what I have here still to show you is the skill sets for different data roles. So we're looking at this T-shaped profile. The idea here is that we have some different disciplines, but depending on which role you are focusing, you should have more deep knowledge on one of those kind of cross-disciplines. So for example, for the data analyst, it is important to have some programming experience or knowledge, like especially SQL or R or Python, but not as deep as the knowledge about the domain itself. So when you are a marketing analyst, you know a lot about marketing, or if you are in the mobility field, you're also supposed to know more about mobility, things like that, because the idea of the data analyst is to be able to report to the business stakeholders using data. So for that, it's very important to have good visualization and communication skills. For example, using Excel, Tableau, having a logical approach in storytelling, and also knowing or being comfortable on interpreting the data. And another important skill is descriptive statistics or hypothesis testing, especially for A/B testing, and knowledge of probability distributions, and also knowing some regression models, for example. That is different from data scientists here. So data scientists, it's also important to have some domain expertise, but more important to have strong programming skills, again, in SQL, R, or Python. More important that than the visualization or communication skills if compared to the analyst. So here it's less deep, the arrow down in visualization and communication. And then the strongest, let's say, skill would be in the realm of machine learning algorithms and statistics. So besides knowing either Python, R, and the specific packages for dealing with data, like pandas, for example, it's also important to know the models, so regression models, classification models, clustering models, and even deep learning ones. So not that you need to know all of them, but you should have some basic knowledge of the model. If we compare now data scientist to the data engineer, so the data engineer, again, the programming and tools, but here would even go beyond just Python, but maybe you also know Java or Scala, and also knowing how to use the big data tools, let's say Hadoop ecosystem, like Hive, Pig, Spark, and understanding databases, understanding how to use Docker, how to use Airflow and Jenkins, those kind of tools for really engineering the solution, right? And then on the software engineering or platforms, also important to understand about data pipelines, data structures, and the platforms that we mentioned already, cloud platforms or even Linux. And comparing the two engineers, so data engineer here in blue and the next machine learning engineer, here the difference there, for example, in the platform side is instead of knowing about the data structures, but understanding more about the microservices infrastructure. So in a way that is more focused on serving the results of the machine learning model. And then it's also relevant to understand more about the machine learning algorithms themselves, or really about the implemented versions that we have, for example, in scikit-learn. Yeah, and then I think, Alexey, you already mentioned this, but we have another slide on some tips or some ideas you have from your experience from transitioning from software engineering to data scientist.
Yeah, so I was thinking like what, like I think I mentioned that at some point, but I want to reiterate on that. So I don't necessarily think that my investment of 2 years into doing masters was the best, had the best return on investment. So I would instead try to pick up the skills that I really need by doing online courses. Like, of course, I just told that certificates maybe are not important, but I think what is important is the knowledge that you get from these courses. And then after reading a book, you don't get any certificate, right? But you still get the knowledge from this book. So just try to pick some knowledge. Do not go you don't need 10 books for that. You don't need 10 courses. Just doing a couple is enough, just to get the general understanding of like what it involves, what kind of models are there, how to set up a cross-validation scheme, and then learn by doing projects. So just do pick up a problem to solve and then really focus on solving this problem instead of trying to learn everything. Just learn enough to solve this problem. And then for a software engineer, I think what like when you already get hired, like for the first full-time position, what really helps is collaborating with other team members, because everyone has their own strengths. So for example, in one company where I worked, in my team, there were people coming from different backgrounds. So I was coming from software engineering. Then there was my colleague coming from academia doing physics and chemistry. And then another colleague was previously a QA engineer. And it was really like we could learn a lot from each other because everyone had their own strengths. And by working together, by collaborating, everyone could learn from everyone else. So because again, we have these T-shapes profiles, and this T probably is different for everyone. But when you take different profiles and you overlay, you put them on each other, then you have a very like a good picture, because a team can solve pretty much everything. And then collaborate with other colleagues who are more experienced in some of the verticals, in some of the aspects, let's say math, because I know that coming from software engineering, that is probably not the best, the strongest side. For me, it wasn't. So collaborate with people who know it better than you. And then let's say if you're trying to implement a paper and if something is not clear, talk to these people and they will explain some of the things. And then getting real life experience, I think, is better than doing courses, and also getting masters, and if possible, try to start working like as soon as possible. Let's say if your goal is to go into data science, then yeah, if you can just let's say you can join a startup and work there instead of doing more and more courses and thinking, okay, I'm not ready, I need to study more. Just start trying to get a job sooner. And the same with Kaggle. I remember when I was before doing Kaggle, I think, okay, I don't know enough. I need to study more. I need to cover this topic. I need to cover that topic. And you just need to do it. Just go on Kaggle and start doing this. And then you realize that everything you learned previously, at least it was the case for me, everything I learned previously was useless for Kaggle because it was a completely different set of skills. And this set of skills was more useful for the actual job than everything I studied in also in online courses. So having this more closer to real life experience Can be from Kaggle, can be from projects, can be from a real job, can be from I don't know, this data for social good initiatives. Like, I think this is the best way of getting the skills.
Yes, I can agree to that. And I would also like to add a plus to the collaboration point, because I think it's very important, and especially in data science, because we are talking about how the field is young and the definitions are still blurry. But I think that's also what makes it so interesting, because it attracts people from different backgrounds that have different strengths, as you mentioned, and different interests also. And working with a team that you can exchange in this level is something that really helps you in learning by doing, and also learning from the others, which is maybe easier than learning from a video, an online course.
Definitely.
And the real life experience topic, I would agree that if it could be some, like if you're doing a master's, if it can be a thesis, or if you're already working somewhere, then this is the real life experience. But I saw here that we have a question that is about that exactly. How would one structure a good project to work on to add to their portfolio? When would a project be considered too simple to self-promote when job seeking? So I think you gave one example that it was pretty interesting, from starting with the data collection, like scraping the website, building some sort of database, and then using that data to come up with a model. I think that's a very complete solution. But also on the other side, if you take on some data sets from Kaggle and you can derive a model and then serve this model so that you have some sort of front end, I don't know, website where people can try out and play with your model. I think that's also another good example.
Definitely. Yes.
I don't know what would be considered too simple.
I don't think, like, again, it depends on the goal. So why do you want to build this project? Like, what do you want to achieve with this project? Is it a side project that you want to, like, do you want to run a launch website and you want to build this as a pet project, or you want to learn a particular skill? If you want to learn a particular skill, you really need to design your project in a way that you learn the skill. So it should be a small project that really emphasizes like this particular thing. Let's say if you want to learn more about Redis, or something else, like I don't know, let's say Redis, because you heard that this is useful and you saw this in a couple of job postings. Just build a project where you use Redis, let's say, as a queuing technology, like for creating queues, and just focus on that, and do like a minimal, like an MVP, proof of concept, where you really learn Redis, then document this, share what you learned, like write a blog post, and move on. Like, I think that is enough. So don't spend a lot of time on doing this. So you learned enough, let's say Redis, and then move enough to pick up the next skill. Because let's say if you're looking for a job, you don't have a lot of time, right? So you want to maximize, like to optimize the way you spend time. So instead of investing all this time into one project, so maybe invest this time into 10 different projects that focus on different technologies that you want to learn. Like, and then it will make your portfolio perhaps more interesting because you have more use cases, and then you will also learn more technologies.
Yeah, that makes sense. Well, thank you. So back to the slides, we have one last part. It's about the orientation on data careers. Chris, would you like to take over? I don't know if you're still answering more questions.
Yes, so I can do that, and then I'm answering. I've done more answers and typed them in and so on. And I've just double clicked, so you can see, if you click in the Q&A on unanswered, you will see some of those answered if you're interested. And particularly if you don't see your questions in the open anymore, it's been answered by me in writing. Okay. Do you want to show me the next slide, or then you need to take me through the slides?
Yeah.
Yes. So market orientation, what is this about, right? It's about where you are in your career and where you might want to go next. And it's also about considering where it is profitable or beneficial to go next, where the interesting use cases are, where the interesting companies are, where what would move your career. And, you know, one is your interest and the other is where is the market and how is this market developing? Okay, and of course, there are ways in which you hear about this kind of like on the grapevine, or you hear from friends, or you can find out at meetups. But there's also sometimes more systematic ways of looking at this. And there is generally data and presentations and overview available that are easily findable on the internet through search engines that you can use. And what I'm doing here, or what we are doing here, is we're showing you one example. So there's data has been collected about AI investment and the return of investment and the relative landscape of industries. And yes, you can see with the headline, it says here, everyone's winning, but some industries are winning bigger. Okay, and if you then look at the two axes, you see that there's sort of like a quadrant where we're talking about high AI investment and high returns. And these are the industries where most is happening. And if you look at what it says there, you're probably also not really surprised. And then there are areas where there's a low investment and the returns are low. So this is actually often where at the moment it's difficult, although I would argue, for example, that financial services and insurance are slowly moving out of that quadrant. But there you go. So there are ways of looking at it. And you can see, for example, that in healthcare and the life sciences investments are high, but the returns are often still in the making, if you so like. So, and I think it's, for you, it's interesting to consider this as you move and as you consider where you want to go, because there is a difference in dynamic between the different industries and companies. So please consider. Next slide. So, and then from stuff that we've done and overviews that we've seen, we would like to point out some key industry challenges that we see, and particularly key industry challenges that we see in Europe. So we're now talking not about startups and also not about large startups. We're talking about the traditional economic landscape, quite prevalent in Europe, because of course, a lot of the companies are a bit older. And what you see here is, right, the first point, you read data volume, accessibility, and quality. My standard quip on this is it's about companies that are looking for the key to the cupboard in which they have the printed Excel sheets. So you do need to see that for many companies, it is the case that they do have IT and they have IT infrastructures, but the IT infrastructure that they have isn't yet that suited entirely to really driving forward data analytics or machine learning. So there can be issues around data volume, accessibility, and quality that if you go to an established industrial player, you need to be willing to address. You need to be willing to do this work. And in the AI Guild, for example, we have freelancers that regularly go and work with traditional incumbent companies and precisely try to fix that problem and also try to help them to replace IT infrastructure that actually isn't suitable for data science. So this is part of what's going on, and you need to be willing to do it, and you need to do some of it before you can do some fancy ML algo. Then the next thing you see here is the trust of customers, stakeholders, and employees, including governance, compliance, and reputation. Very long, but what in essence it means, you need to do talking. You need to do some good talking. You need to be able to visualize, communicate, get things across, and get people on board. And you need to get people on board in the sense that you're not dealing with data natives. You're dealing with people that are coming to this at some point in their career that they've already been enjoying and now need to get their head around it, and particularly also in this sense need to learn to trust it. They need to believe that what you will do will bring value, and you need that because you need budget, you need willingness to implement, you need other people to change the way things are doing. So this is part of the game. And then the final one here, it says competence of employees, management, and the company itself. So we've had this many times now. It's early days. If you go and do this, you're still in many ways a pioneer, particularly if you go there to the more traditional industry players. So you need to be aware of that. And you, I think, to some extent, need to understand that you need to give it time. Yeah, there are some obvious advantages in working for a well-established, particularly larger company, a corporate with its, secure streams of revenue, established company culture, long-term employment, and so on and so on. But on the other hand, this is, in terms of trade-off, something you need to look at. Next slide, please, Dania. And then, so if we switch it around, there are some startup challenges, and then surprisingly also sometimes around data volume, accessibility, and quality. So there are, of course, actually the larger companies. And Alexey, who is here with us today, or if you think from OLX, or if you think about Zalando, or you think of some of the big fintechs like Klarna and so on, they've been around for a while now. They run services that are that thrive on data. They have the volume. But if you have a smaller startup that's only getting started, and even if it's an AI startup, I mean, the question is really, where's the data coming from? Do they have their own data? Can they rely on public data? Do they need data from clients? This, by the way, isn't just about startups, but it's also about if you go and work for a consultancy firm. So my favorite one of this is somebody I know who went to work for a consultancy firm on what seemed like a really, really exciting project. And then it turns out 6 months later, we have no data. So you need to look at this and you need to understand whether the baseline is there and what you can do with it. And then if you go and join a startup, please, check that they have enough funding and runway, particularly if they're still small and early. And then you also need to check the expertise levels and the team size. So with Alexey today, we have a lead data scientist, and OLX has a big team, and other larger startups have big teams. But I've also come across the startup where the lead data scientist is 1 year out of university. Now, that's great for the lead data scientist that's making such a fast career, but it also means that if you want in your first job to learn a lot of things and have mentors and learn from others, more established practitioners, that is not possible. So you need to look at this and then understand whether you like it, whether you kind of like this self-starting mode, and if that works for you, great, or you actually would like some more experienced people around you, and then this may not work so well for you. So please look at it and be aware of this. And then the wrapping it up or bringing it together. So please, one is your skills and your skills development, but take a minute. It doesn't take you long to go and observe the market. Perhaps you can also, for example, type in your favorite search engine that you want a market map of AI startups or a market map of NLP startups or what have you. And you will find information, also visual information, that will give you a quick orientation of what's going on. Then look for a match between the employer's needs and your skills profile, so that it's also easy for the employers that you apply to kind of understand that you bring something. And also, for example, this includes whether you bring skills that are suitable for a startup that needs to be quick and fast. Do you really enjoy consulting in the sense of helping other people and being analytic, or are you actually really looking for a job in a larger company? And this helps also the employer to understand that you've thought about it and that you are really looking for that type of company that they are. And the final line here is scan the industry and startups for the most promising AI use case. So go and find out where you think you want to go and where things are going, and if you can, find a way of working on that. So thank you. I think I'm done with that. Oh, here comes the
Yes.
free book.
Thank you, Chris.
You're welcome.
Yes, Alexey.
Yeah, so if like I talked about my book already, and if you want to get a free copy, so please enter your email in the form, and then you can get a chance to win it. And also, if you can leave any feedback to me there in the form, like or just write something to me, you can do this through the form, and you will also get some contact details. Yeah, so if you're interested, please leave your information, and and I guess now it's the last slide, right? So now we still have some time for questions. Yeah, but can you keep it on the previous slide so people can use a core? Yeah, thanks.
Yes, let's do that. So we still have some questions, and my cat joined. I think he is hungry. Okay, so we can answer some of the questions that are left. I think there is one here. When we do machine learning or data science, do we always check the assumption of the statistics? That is, check if correlations with variables are too high. Sometimes I have asked myself if I should check the assumption of the statistics while feeding a model.
Well, I guess I don't think it's super important. I mean, it's good to know that you, like, if there are correlations in the data, it helps you understand the data better and know just know your data better. But when it comes to actually modeling, then for the model, oftentimes it's not really important if features are correlated or not, because there are things like regularization, or some families of models do not care if there's correlation or not. They just work. Let's say if we take tree-based models, like random forest, they would just half of the time will take one feature and use it, half of the time will take another feature and use it. But then when you try to interpret these results, then you will not be able to see that this feature, maybe if you combine these two, they are super important, but they will be only half as important when not combined. So it just to summarize somehow, it still makes sense to understand your data, but when it comes to the quality of the model, it doesn't necessarily will have big influence. Sometimes actually it helps to remove features, but often, like in my personal experience, removing features helps not necessarily to improve the quality of models, but just make it simpler to deploy. And then if it also improves the quality of the model, it's a big advantage. But I think the main advantage comes from like, you don't need to calculate this feature, you don't need to use it, so your model becomes simpler and it's easier to deploy. So doing this is very helpful, of course.
Yeah, I agree. I mean, then it goes a bit to the direction of the theory of the models. So some of the models will not care if there is correlation. Some models will be affected by this. But in any case, it would be an idea to also lower the dimension of your problem. That might help in the running time, not only because you have less features, so you have less data preparation time, but also the model calculation might run faster, and serving that model might be simpler at the end. So I think it makes sense to check for that.
Mm-hmm.
The other question is from Sam. Is the job of data scientists at risk of being automated, especially by technologies such as AutoML? What is your opinion on this?
My opinion is, like, if you think about this, like, let's say we want to predict, we want to build a model for predicting the price of a car. So this AutoML model will not go to this website, will not scrape this data, or will not go to our database, will not get the data, will not prepare it in the right form, right? So what like, somebody needs to do this, right? Somebody needs to go to the database. Somebody needs to run the SQL query. Somebody needs to process this result, to remove, maybe to see if there is data missing, maybe there are some problems with that, fix that, and only then the result goes to this AutoML algorithm. So everything before that and everything after also, like, it's still difficult to make it automatic. And even before this data preparation step, one important thing that we didn't really talk about today is this business understanding step. Like, when you really want to understand what is the problem you're trying to solve, and will actually machine learning help. And you want, at this step, you want to translate the vague business requirements. Like, somebody comes to you with a problem, you want to translate this problem into something else, into a language that data scientists can understand. Like, so you want to be this translator, and AutoML cannot do this, right? So still, like, there should be a person who understands when machine learning is the right tool, how to measure the success of machine learning solution, how to prepare the data, and like, it's very difficult to automate. So people will still need to do this. And the way I see it, to me personally, like, training a model, especially when it comes to hyperparameter tuning, is a mundane and boring task. Like, first few times it's fun, but then, like, let's say you're training a neural net, and then you change one little parameter and wait a few hours when it finishes. To me, it's not fun. So some people like it. I personally don't. I prefer that a computer does that. So just, okay, here is the data set, here is a model, please tune it and squeeze the best from this data. I don't care how you do this, just do it. And then like a few hours after that, I can see, okay, like it makes sense, and just use it. So instead of doing this task myself and spending a lot of time, I do something else that can be more valuable. So I don't think AutoML is going to replace a data scientist anytime soon.
Yes, I would agree with your opinion, because I think there are a lot more to a data scientist, let's say, common task set than just hyperparameter tuning. So that part is for sure something that it can, if it can be automated and leave more space, more time to do other interesting stuff, especially on this idea, for example, if you want to have the model tuned, but you need to define what is your goal with this, or how do you measure the success? And even if it's some kind of optimization problem, then you need to define what is your objective function. I don't know if this is something that can be automated. You have to understand the business and know how to translate that into the data available. And then you can come up with a machine learning solution if required. Okay, we have here one question from Anonymous. What are the subfields of machine learning and AI that will become much more popular than they are now? I think this is a question of maybe you have a
crystal
hunch.
ball, sorry.
Yeah.
Well, I think what personally I like about this is it becomes more accessible. Machine learning becomes more accessible. So like 8 years ago, when I was trying to get into this field, people would tell me
Yes.
that I need to have PhD and other things. I think now
Yeah.
to some people it became more easy to get. Well, on the other hand, again, now I think the bar is raised for when it comes to software engineering skills. So maybe for some it's more difficult. But I think there is a tendency, even with this bar for software engineering, it's getting lower. There is this, maybe you heard about this no-code movement, when you can create prototypes without coding at all. You just do a prototype by clicking the mouse, and then you have a working application. There are many tools for this no-code, and I like where it's going. So I'm really curious when we will see more solutions like that, especially that also use machine learning. So right now it's mostly about like, okay, you can create a Twitter with just, clicking a mouse and design the entire website that works. That's cool. I think soon it will be possible also to, just drag and drop machine learning components there, and lowering the entry bar to the field even more. So I think in this way, like, let's say, if you develop this business understanding, if you know how machine learning can solve your problem, but you do not necessarily have the skills, the engineering skills, with these tools, my hope is you'll still be able to solve your problem using machine learning without having to hire a team or two teams of software developers to solve it. Let's see where it goes. Maybe probably in 5 or 10 years, it will be completely different, but I hope to see tools like that coming up.
Yes. I would also hope to see that. Yeah. So the lowering the bar is true in a lot of senses, but also because people understand better what is required to be a data scientist. Like, as you were saying, maybe 5 years ago, it was something that was for PhDs, and now it's understood differently. We get to see what happens next, the next 5 years. There's another question here anonymously posted. How will software engineering skills be tested during interviews for data analysts or data scientists? Do you need to solve linked list or binary tree problems, for example?
Well, so I will not tell you the question I ask during the interview, but it's pretty simple. So it involves one loop and a few ifs inside. So I think with enough time, I usually give half an hour. So even though I know that interview can be stressful, that it's a relatively simple task. So when I do this, I usually just check if a candidate knows how to program in Python. And sometimes, yeah, it's not always the case. Sometimes, unfortunately, people tell things on their CVs that are not true. And this is one of the ways to check that. But apart from simple coding, and then yeah, we also have a use case like a home task assignment, where we actually look at the code. It's something also relatively small to test. And I think this is the case for OLX. For some companies, it's different. Let's say I remember a couple of years ago, I interviewed with Zalando, and for Zalando, a data scientist is a software engineer who can code, basically. And they would, I remember they gave me a piece of paper. There was something already written in Java, and they would give me some sort of lead code like problem, a lead code style problem, and ask me to implement this with using a pen and a piece of paper there.
Okay.
Yeah, so it really depends on the company. So I don't know if
Yeah.
Zalando is still doing this, and I think so. They know what they want to get from data scientists. That's why they are testing this. So they apparently want that data scientists be very capable of software engineering. So it really varies across companies. So it can be very different.
Yeah, I think it's pretty common to find this home assignment. So take home assignment, and then you have to program something and show a solution and present your solution. I also think, like in the direction of what you were saying, that each company has a different way of testing. But as a candidate, it can give you a lot of insights about what the role is actually about when the company gives you specific kind of task. So what you were saying, this example from doing some Java coding, then that is what is
Yes.
expected of the candidate. And I think this is what you can expect to be doing it at the job if you get it. Okay, last question, because we're also a bit late, 7 minutes already past time. Erin asked, what is the minimum requirement for someone to get internship in machine learning engineer? And also, how often does company hire interns remotely?
Yeah, so I think the main requirement for that is luck. So it's very tough. So and usually, like let's say when it comes to OLX, we don't have a really high bar when it comes to interns. So we just really check if an intern candidate is enthusiastic about things and can learn. So potentially that like probably every graduate students, any graduate student can fit this criteria, right? So this means that the competition is tough, and usually it means like to actually get this position, you just need to appear at the right time in the right place, right? So okay, you see a position, you apply, and then because it just appeared, you were first, and then yeah. So unfortunately, there is no easy answer. So just that, and then I think having connections help. So let's say if you know somebody who is hiring, but they haven't posted it yet, so you can just write and ask, hey, do you have any intern positions? And people do ask me that question. And once somebody asked, and we actually did have
Cool.
we don't have now, so please don't like if like I don't know, like 1,000 people write me. We don't have now right now. I think we have one in Portugal, or at least soon, but not in Germany. Yeah, so
Yeah,
for
but have you
Portugal,
heard of kind of a remote hire for
yes.
internship?
So for example, my intern who recently finished his internship, so he was working remotely from Munich even before the pandemic.
Okay.
So I think that's fine. And now with the pandemic, I think it's even easier. Um, but well, for interns, probably at least when it comes to OLX, they are more temporary with the possibility to switch at the end. But still, so they have like temporal contracts, and probably for interns, it's easier to agree to negotiate like a remote contract. While for full-time employees, right now, we expect that at some point when the whole thing is over and we're back to normal lives, then people will go to the office, right?
Yeah.
So interns maybe have more flexibility for that. It again depends really on the company. So probably it's the best the best way is just to ask, or yeah, somebody maybe, if there's somebody you know who might be hiring interns, just ask them.
Yes, thank you. I think that those were all the questions. Or no, there's some open. Okay, someone is asking, so Katarina is asking if she can contact you about the opening in Portugal.
Yes, please. And
The
yeah,
job.
so right now I really have to go, but if you have any questions, so you know my contact details on LinkedIn, Twitter, you can find me on my website. There's also my email, so just feel free to reach out also in Slack, in AI Guild.
Yes, thank you. Thank you very much. I think we managed to answer all the questions now. So I see here 33 questions answered. But if any other questions come up, just please contact us on LinkedIn and join the AI Guild, and we can then exchange more on our Slack workspace.
Thank you.
Thank you, Alexey.
Have a nice evening.
Thank you, everyone, for joining. Bye-bye.
Goodbye.